Hi everyone! Today, we'll take a closer look at Chapter 4, Test Analysis and Design. We will learn the section Equivalence Partitioning in the topic Black Box Test Techniques. Let's begin. This video is a part of the ISTQB Foundation Level Preparation course on Udemy. For more information, check the description below the video. Let's find out what study materials we can use for self-study and what kind and difficulty of the questions you can expect on the real exam. First of all, the latest version of the syllabus. Unfortunately, the syllabus is written very abstractly without examples and additional explanations, which are necessary for the questions of the K3 level. That is why we created this video to give you additional explanations on how to apply the technique in practice. However, we will still start with self-studying. In addition, we advise you to read the same section in the previous version of the syllabus version 3.1. It has several examples with explanations of the test design technique. Additionally, you can read information about the equivalence partitioning in the book Foundations of Software Testing ISTQB Certification by Rex Black. This is one of the authors of the exam and his explanations will be very helpful. Within this thread, it doesn't matter which version of the book you find, 3rd edition or 4th edition, both have valid information. The problem is that the books are not freely available and they are quite expensive. But maybe they are available for your organization, or you might be lucky enough to find at least the 2011 edition. Now, let's learn how you can use the theory written in the syllabus in practice. You can pause the video and familiarize yourself with the content of the slide. We presented the theory of the syllabus in a logical sequence of actions that must be done in a simplest test on equivalence partitioning. There are only 2 steps. Let's check how the theory works in practice. Let's say we have such a user story, very simple. As a user, I want to login field on the application's login page to accept usernames that are more than 5 and less than 13 characters in length. Let's move on to the first step of using equivalence partitionings. Divide a set of test conditions into partitions, and you need to start with valid partitionings. There is not much information in the user story. All that we know is that the login field should be more than 5 and less than 13 characters in length. When we're dealing with a number of values, we recommend drawing a line of values in order to visualize equivalence partitions and display valid and invalid classes already on the value line. Let's define the limits of the valid partition and put the values on the line. What is important to remember is that the limits of valid equivalence partitions are the minimum valid value and the maximum valid value. In the ISTQB question, the wording is done in such a way as to confuse you. Although the numbers 5 and 13 are mentioned, they are not actually in the range of valid partition. We can mark them in round brackets, or write the minimum and maximum value of a valid partition in square brackets. Another option is to indicate the range values in the description of the questions with the help of symbols: greater than, less than, greater than or equal to, less than or equal to, which will have the same meaning as round and square brackets. And you have to be very careful with the values on the edges of the partitions. After all, it depends on them whether you will be able to answer the questions correctly. In our case, the minimum valid value is 6, and the maximum valid value is 12. This is the most important step. If you incorrectly determine the minimum and maximum value of a valid partition, then all your subsequent efforts will be in vain. Let's move on to the next step. After we have identified the valid partitions, we need to identify the invalid partitions. In this simple example, it is easier to identify invalid partitions because we have already identified valid partition. If the number of characters is less than 6, then it is invalid value, and if the number of characters is more than 12, it is also an invalid value. In fact, even in this simple example, defining invalid equivalence partitions is more difficult than it seemed at first glance. Very often, you won't have enough information to determine the limits, maximum or minimum values of invalid equivalence partitions. As in our example, we don't know what the minimum value is. It could be 0, it could be 1, or it could be even the -1. The same problem with the maximum value. It could be 30, it could be 1,000, a million, or infinity. The good news is that ISTQB writes the questions in such a way that if you don't have enough information to do something, then you don't need to do it. We will talk about this in more detail in the second part of the video, where we will show how to answer questions about equivalence partitions based on ISTQB sample exams. Let's move on to the last step. To achieve 100% coverage with this technique, test cases must exercise all identified partitions, including invalid partitions, by covering each partition at least once. Equivalence partitioning is a very simple test design technique. You need to write one test case for one partition. In our case, we have 3 partitions respectively. In order to get 100% coverage, we need to write 3 test cases. Let's select the first test case. As you can see, we do not need to know the exact minimum and maximum values of invalid equivalence partitions. If we know that 5 or fewer characters is invalid value, then we can write several invalid tests. For example, a value with 4 characters, user. This could be our first invalid test case. Equivalence partitioning coverage in this case will be 33%. You need to divide the number of equivalence partitions covered by test cases by the total number of equivalence partitions and multiply by 100. In this way, you can determine the percentage of test coverage. For example, if we have only one test and the number of equivalence partitions is 3, then the test coverage will be 33%. Accordingly, in order to get 100% coverage, we need 2 more tests, one for a valid partition and another for invalid one. For example, 11 and 14 characters respectively. Thus, with 3 tests, we achieve 100% coverage. Test coverage is a very simple concept, but due to the fact that it is not described in detail and not explained in the syllabus, students have many problems with determining the percentage of coverage. For example, let's say we have 2 tests for valid partition, 11 characters and 7 characters. What will be the percentage of test coverage in this case? 60%, 30%, or 25%? The correct answer is 33%. Even if we write 5, 10, 100 tests for one partition, it does not change the percentage of test coverage. After all, only 1 out of 3 partitions is covered by tests. Remember that for 100% test coverage, you need to have at least 1 test per partition. And whether there will be 2 or more tests for one partition, it does not affect the percentage of test coverage. This is the simplest example of using the equivalence partitioning technique. Unfortunately, ISTQB questions are much more difficult. But in order for you to be able to answer complex questions, we have to start with the simplest examples. And another example of using the test design technique is non-numerical values. Let's say we have such a user story. As a user, I want a login field on the application's login page to accept usernames that are alphanumeric. Students have more problems with non-numeric equivalence partitions, especially with invalid partitions. You have to follow the same steps as with numeric classes, and it will lead to success. The first step is to divide a set of test conditions into partitions, and you need to start with valid partitions. There is not much information in the user story. All that we know is that the login field should be alphanumeric. When we are dealing with non-numeric values, we recommend drawing a circle to visualize equivalence partitions and display valid and invalid classes as segments in the circle. We will have only one valid partition, alphanumeric value. For example, test user 007. This will be the only valid equivalence partition according to the user story. Let's move on to the next step. After we have identified the valid partitions, we need to identify the invalid partitions. It is at this step that most students have many problems and questions. After all, in a real project, you have a lot of options for invalid values that need to be tested. For example, empty field, only letters, only numbers, or only special characters. All of these can be invalid equivalence partitions. Even more, it's probably a good idea to test each special character individually. After all, some programming languages handle some special characters well, but need additional lines of code to handle other special characters. We advise you not to overcomplicate the selection of invalid equivalence partitions. Follow the ISTQB description of the questions. We know that sounds like a hell of an advice, but we owe you a better explanation. What we mean is that if there is a little information in the description of the question, then do the minimum, and by bare minimum we mean that 2 invalid classes for numerical equivalence partitions, less than the smallest valid partition value and greater than the largest valid partition value. With numerical values, it is easy to determine the equivalence partitions, as we saw in the previous example. Just remember that no matter how many valid numeric partitions there are, they must always start with an invalid partition and end with an invalid partition. With non-numeric values, it is also simple. Only one invalid equivalence partition for non-numeric values. If there are no additional details, restrictions, or conditions in the question description, then non-numeric values have only one invalid equivalence partition. Accordingly, we will add these 2 rules for non-numeric and numeric equivalence partitions to our checklist. Since we do not have a numeric value, we need to define only one invalid equivalence partition. It can be any value, an empty value, only numbers, only letters, only special characters, or all together. According to the equivalence partitioning test design technique, you do not need to test all values individually unless invalid partitions are specified in the question description. Only one invalid partition will be enough, so we have 2 equivalence partitions in total. Let's move to the next step. To achieve 100% coverage with this technique, test cases must exercise all identified partitions, including invalid partitions, by covering each partition at least once. This means that we only need 2 tests to achieve 100% coverage of equivalence partitions. One is valid, for example, test use 007. The other is invalid. Invalid value can be any, only numbers, only letters, empty value, special character. Any of these values may be invalid. If we had a more detailed question, then more individual invalid partitions could be identified. Again, if we tested only the valid partition, then the test coverage would be 50%, because only one of the 2 partitions will be covered by tests. And even if we had more than one test for a valid partition, the percentage of test coverage would remain at the level of 50%. To achieve 100% coverage with this technique, test cases must exercise all identified partitions, including invalid partitions, by covering each partition at least once. And even if we wrote several tests for invalid partitions, then the test coverage would be at the level of 100%, because equivalence partitioning is a simple technique and requires only one test case per partition. Let's check one more example of a simple user story. Non-numeric equivalence partitions can have more than one valid partition. For example, we have the user story. As a user, I want to be able to watch videos in 3 different formats: Full HD, 2K, and 4K. The first step is to divide a set of test conditions into partitions. This time, since we have already understood the basis, we will highlight valid and invalid partitions at once. There is not much information in the user story. All that we know is that the user should be able to watch videos in Full HD, 2K, and 4K. These are 3 valid equivalence partitions, which are marked in green or pie chart. But as always, the problem arises with invalid partitions. You can handle screen resolutions as numeric values and define 2 invalid partitions, HD and 8K. Thus, we will have 5 equivalence partitions, 3 valid and at least 2 invalid. Or you can handle the screen resolution as non-numeric and distinguish one invalid partition. It can be HD. It can be both HD and 8K, or even other resolutions. Thus, we will have only 4 or equivalence partitions. 3 valid and only 1 invalid. Correctly identifying invalid partitions is very important for calculating test coverage. After all, in one case, 4 tests are enough for 100% coverage. In another, at least 5 tests are needed. As you understand, both options can be correct, both with 1 invalid partition and with 2 or more. It all depends on the context. And to find the context and details, you should look at the description of the question. And this is what we were lucky with. Although the ISTQB question descriptions can be vague and blurry, in the vast majority of cases, the creators of the exam and training centers understand the complexity of the questions and therefore provide certain clarifications. To make it easier for us to answer questions, in the question about the resolution, most likely there will be a clarification. For example, there can be an additional sentence, something like this. What is the minimum number of test cases required to cover all valid equivalence partitions? So the question will emphasize that only valid partitions need to be tested. That is, we will not need to determine invalid partitions at all. Another example of restricting to only valid partitions can be more creative. The question may describe some kind of limitation, and this is always done with a certain purpose, so these clarifications cannot be ignored. For example, the question may contain this kind of sentence. The app has a built-in validation mechanism that will not allow you to use other video formats, which means the same. We don't need to determine invalid partitions at all. That is why carefully read the description of the question. It can greatly simplify the search for the right answer. This also applies to invalid partitions. The question can emphasize the fact that invalid partitions need to be tested. For example, the HD format was removed from the backend and should not be displayed in the dropdown. In this case, we need to test only one invalid partition. That's why, read the description of the question very carefully. Mostly it contains hints that should help you simplify the task. Although sometimes the task description contains distractors, such as extra information that does not affect the definition of partitions. We will talk about this a little later when we check examples of exam samples. We also understand that most likely you have a question and what to do if there is no clarification in the question. In the example from the screenshots, determine 2 or more invalid partitions or only 1. We advise you to rely on your gut feeling, and if it is silent, then for non-numeric partitions. Define only 1 invalid equivalence partition. That's why 4 test cases are enough for 100% test coverage, and this would be a good ending for a long explanation of the equivalence partitioning test technique. But that's not the end. We have only reached the most difficult and interesting part of the video. Most ISTQB questions have multiple sets of partitions. That makes it very difficult to find the right answer and confuses students. We have combined the previous 2 examples into one, so that you can better understand what we mean. As a result, we have the following user story. As a user, I want the login field to accept usernames that are alphanumeric and between 6 and 12 characters long. This time, 2 conditions are combined. The login field accepts usernames that are alphanumeric and should be 6 and 12 characters in length. And this makes changes in the use of technique. When we have more than one set of conditions, then we have an additional step in using the equivalence partitioning technique, which means that a test case will cover partitions from different sets of partitions. However, we start in the same way as before. We need to divide a set of test conditions into groups, or valid or invalid partitions. Since we have already defined both equivalence partitions set separately, we will not delve into the details at this step. We have 5 equivalence partitions, 2 valid and 3 invalid. Difficulties begin at the next step in using the technique. The test case will cover partitions from different sets of partitions. When values from valid partitions are used in test cases, they can be combined. This means that unlike the previous stage, where we had only one data set, now each test case will cover two partitions. Our positive test must have a value that is alphanumeric, and that is between 6 and 12 characters long. For example, the value user007. It has both letters and numbers, as well as 7 characters in total. Thus, one test covers two valid partitions at once, the second and fourth. If you have multiple sets of partitions, then sometimes it is impossible to write a valid test that will cover only one valid partition. The test must cover two valid partitions, as in our example. Otherwise, the test case itself will be negative and invalid. And this leads to the next step. When values from invalid partitions are used in test cases, they should be tested individually. If you want to write a negative test to test the first equivalence partition, then the correct value will be, for example, user1. This value will be less than 6 characters long, but it must also be alphanumeric. That is, the value is invalid for one equivalence partition set, but valid for another set. Because when values from invalid partitions are used in test cases, they should be tested individually. We cannot test two invalid equivalence partitions at once. The value cannot be non-alphanumeric and less than 6 characters at the same time. Failures can be masked when several failures occur at the same time, but only one is visible, causing the other failures to be undetected. Let's visualize this on a real example on the Gmail registration form. When we enter a value, the user1, we see an error. Sorry, your username must be between 6 and 30 characters long. And this is exactly what we expect. After all, the value is alphanumeric, includes both letters and symbols, and we test the length of the characters. Now, if we want to test special characters, then we choose a value that has more than 6 characters, but which includes a special character, for example, test user, and the @ sign. Then we see the error, sorry, only letters, numbers, and full stops are allowed. Again, this is exactly what we expect to see, because the length is valid and the value includes an invalid character type. And now we have a question for you. What happens if you still write a test that both has few characters and includes special characters? We will see two failures at once, and we will be told that the value is too small and includes invalid symbols. This time we will get only one error. Sorry, only letters, numbers, and full stops are allowed. The first equivalence partition is untested. Accordingly, we expected to have 80% test coverage, but we have only 60. We hope this example will help you understand why failures can be masked when several failures occur at the same time, but only one is visible, causing the other failures to be undetected. That is why we need 4 tests for 100% test coverage. One valid that will cover 2 valid equivalence partitions at once, and 3 invalid, each of which will cover only one invalid equivalence partition. One value will be alphanumeric but less than 6 characters long. Another value will be alphanumeric but more than 12 characters long. And one value will be between 6 and 12 characters in length, but will not be alphanumeric. We will cover more examples based on ISTQB sample exams in a minute. First, let's finish with the theoretical part. We have discussed almost all the theoretical nuances of using the equivalence partitioning test design technique. There is only one sentence left, which brings a lot of confusion to many students. Each choice coverage does not take into account combinations of partitions, and we need another user story that will help explain it. Let's complicate the user story we discussed earlier. As a user, I want to be able to watch videos in 3 formats: Full HD, 2K, and 4K on 3 devices: iPhone, iPad, and MacBook. What is the minimum number of test cases required to cover all valid equivalence partitions? We will not dwell on the details here. We have two sets of data, 6 equivalence partitions in total. And there are no invalid ones because that is what is written in the user story. It seems that everything is simple, but many students get confused when they write tests. They start writing combinations and want to test all screen resolutions with all devices. As a result, they got 9 test cases. But this is wrong. Each choice coverage does not take into account combinations of partitions. You only need 3 tests to cover 6 equivalence partitions. Full HD resolution on iPhone, 2K resolution on iPad, and 4K resolution on MacBook, or any other combinations. This is not important because if you use the equivalence partitioning test design technique, your task is to test all equivalence partitions, not their combinations. Lazy testers are happy to hear such an answer because they think that it makes their life easier. But the truth is that the equivalence partitioning test design technique is not ideal for non-numeric values. Sometimes it can be used and it is important to know how to do it. But in this particular example, it is better to use a different test design technique, decision table testing, which we will talk about later. There will be questions on the exam where equivalence partitioning is used specifically for 2 or more non-numeric values. This is done so that you better understand this technique and know how to apply it. That's all. We discussed all the theoretical and practical aspects of applying the equivalence partitioning test design technique. We hope that it is now clearer to you and that it will be easier to answer ISTQB questions and also to use it in practice. Let's try to use what we have learned about the equivalence partitioning test technique in the example of questions from the official ISTQB exam samples. There is a 100% chance of having one question of K3 level on the exam ticket. The K3 level questions are the most difficult. Some you can answer in 1 or 2 minutes, but some questions are so twisted and confusing that you can spend 10 or more than 10 minutes on them. In the new sample exam version 4.0 document, we can find the following question. Those who want to try to answer the question themselves can pause the video. Let's find the answer to it in the study materials. In the simplest case, we have only 2 major steps for applying the equivalence partitioning test technique. However, when you are dealing with ISTQB questions, you should not immediately try to apply the technique. You need to start by reading the description of the question very carefully. Mostly it contains hints that should help you simplify the task. Let's check it. First of all, we need to find out whether we have one set of partitions or multiple sets of partitions. We see that there are multiple partitions, a floor, and a garden type. This means that we will have not 2 but 3 major steps in applying the equivalence partitioning test technique. The second step will be related to dealing with multiple sets of partitions. Let's take a closer look at the question description again to find more similar relevant information. We can find 2 restrictions that will greatly simplify our task. The first limitation is that only apartments on the ground floor have gardens, as it concerns the second step of applying the equivalence partitioning test technique. We will add it as a separate item in the second step, in order not to forget about this restriction. Let's take a closer look at the question description again to find more similar relevant information. And we can find one more restriction. The form has a built-in validation mechanism that will not allow you to use the search criteria that violate this rule. This is a fancy way of saying that we should not consider invalid equivalence partitions. As you know, when we have to use the equivalence partitioning test technique, we have to divide a set of test conditions into partitions, and remember that invalid partitions should be tested individually. However, since we have the limitation that the form has a validation mechanism, then we can cross out these 2 steps. This will greatly simplify the process of finding the correct answer. Now that we have carefully studied the description of the question, we can start applying the equivalence partitioning test technique. First of all, we need to define valid partitions. This is a fairly simple task. We have 3 valid floors: ground floor, first floor, and second or higher floor. We have 3 valid garden types: no garden, small garden, and large garden. 6 equivalence partitions in total. We can write 6 tests accordingly and get 100% test coverage as a result, and that is exactly what we were asked in the question. As you can see, there is even an answer option where there are 6 tests. This is a distractor. In the K3 level questions, the distractors are different from K1 and K2 levels. Mostly, these are incorrect answers aimed at those who do not understand how to apply the test technique. The answer with 6 tests is incorrect because of the second step of the applying the equivalence partitioning test technique. When we have multiple sets of partitions, the values from valid partitions are used in test cases. They can be combined. So 6 tests is the wrong answer, and we need to combine floor tests with garden type tests. And there is also a hidden distractor. Another option is to combine 3 floors with 3 types of gardens. As a result, have only 3 tests, and that could be the right answer. As we can see, even answer option A has 3 tests in total, but this answer option is a distractor. As you remember, we have limitations. Only apartments on the ground floor have gardens. We even added it as a separate item, and it's time to determine how it affects the design of test cases. Let's start from the beginning, but now let's take into account the limitations. Let's start with the first floor and the second floor. They cannot have either a small garden or a large garden. The only option left is the no garden type. Therefore, we write 2 test cases. First floor and no garden. The second floor and no garden. Thus, we have covered 3 equivalence partitions. We need to cover the ground floor equivalence partition and the types of gardens available for it. And for the ground floor, all 3 types of gardens are available. And this is where some students can make a mistake again. They can write 3 test cases for the ground floor and no garden, ground floor and small garden, ground floor and large garden. In total have 5 test cases. For such students, ISTQB has prepared a separate distractor, answer option C, 5 tests, but this is an incorrect answer. You have to remember that each choice coverage does not take into account combinations of partitions. And we already have not 1 but 2 tests for the garden type, no garden. Accordingly, we do not need to additionally cover it with tests. That is why we write only 2 tests for the ground floor and small garden, ground floor and large garden. And thus, with only 4 tests, we get 100% coverage, and that's exactly what we were asked about. Accordingly, the correct answer option is B. 4 is the minimal number of test cases to achieve 100% coverage. Using the example of this question, it is very well illustrated that the most important thing in applying of the equivalence partitioning test design technique when answering the ISTQB question is reading the description of the question very carefully to identify constraints. Let's check one more example of the ISTQB question. In the new sample exam version 4.0 document, we can find the following question. Those who want to try to answer the questions themselves can pause the video. Let's find the answer to it in the study materials. Our basic approach is to go through all the necessary steps to apply the equivalence partitioning test technique. And we need to start with reading the description of the question very carefully and try to find information there which can affect the basic approach. Let's check the question one more time. To be honest, this question is quite specific. As you can see, there are no restrictions or constraints there. The difficulty of the question is how exactly to determine the equivalence partitions. Accordingly, we proceed to the first step of applying the test design technique, defining the valid partitions. Let's check variables in the question description. To be honest, this question is so twisted and unclear that defining valid equivalence partitions is not an easy task. On one hand, everything is simple. On the other, there is a lot of text and information in the question, which is written specifically to confuse us. Long story short, You need to figure out that we have only one variable. For every 10th wash, the system gives a 10% discount, and for every 20th wash, the system gives a further 40% discount. And on the basis of this variable, we must determine the equivalence partitions. We can define two valid equivalence partitions, 10% discount and 50% discount. We know that by reading the description of the question and seeing the numerical values of the number of washes, it looks like we need to determine the equivalence partitions based on the number of washes. But in this example, we have to use the output data, discount percentage. The number of washes will be our test cases, not the equivalence partitions. We'll get back to that in a minute. Let's move to the next step of applying the equivalence partitioning. We need to define the invalid equivalence partitions. And we know that we need to define only one invalid equivalence partition for non-numeric values. When you have a set of non-numeric values, the simplest invalid test is the exact opposite of the existing value or no value. Because of this, we allocate a standard invalid equivalence partition, no discount. In fact, the absence of a discount is not an invalid value. This is a valid value. But this is the easiest option to determine that there is a third equivalence partition, and we will perceive it as invalid. But how exactly is someone supposed to guess that you should apply equivalence partitioning not to the number of washes, but to the percentage of the discount? And then also guess that the absence of a discount is a separate valid equivalence partition. We do not know. Let us know if you have problems with this question, and if you were able to answer it yourself without help. Let's continue with our general approach. The next step is related to the multiple sets of partitions. And we ignore it, as we have only one set of partitions. We can ignore that each choice coverage does not take into account combinations of partitions, for the same reason. We have the last step left to achieve 100% test coverage. This is important to check with this example of values so that it's easier to find the correct answer to the question. According to the variable, for every 10th wash, the system gives a 10% discount, and for every 20th wash, the system gives a further 40% discount. The key values are the 10th and the 20th. Let's start with the simplest example. If we want to write a test for equivalence partition, a 10% discount, then the 10th wash will be the easiest test. Accordingly, for the equivalent partition, a 50% discount, the test will be the 20th wash. For the equivalence partition, no discount, there will be one wash. Other values can be, for example, the 30th wash, the 40th wash, or the 9th wash. Since the description of the question is written very confusingly, we needed to explain how the number of washes interacts with the discount percentage, from the point of view of the equivalence partitioning test technique. Now we can move on to answering the questions. We have 4 sets of values. Each of these has a certain test coverage. And we need to determine which of them covers the largest number of equivalence partitions. For this, we will use our scheme and table, and we will substitute the values from the answer options in the table and see what the test coverage is. Answer option A has 3 values, 19, 20, and 30. 19 washes cover the third partition, no discount. 20 washes cover the second partition, 50% discount. 30 washes cover the first partition and 10% discount. In general, this is 100% test coverage. And most likely, answer option A is correct. But let's check the rest of the answer options as well. Answer option B has 3 values, but 2 values, 11 and 12 washes, cover the same third partition, no discount, twice. 20 washes cover the second partition, 50% discount. As the result, this is 66% test coverage. Let's check the rest of the answer options. Answer option C has 3 values, and the situation is similar to the answer option B. This time, 2 values, 10 and 50 washes, cover the same first partition, 10% discount twice. Because of it, This is 66% test coverage as well. Let's check the last answer option. Answer option D has 4 values, but the percentage of test coverage is the same as answer options B and C, 66%, because only the first and third equivalence partitions are covered. Therefore, the correct answer option is A, which has 100% test coverage. As you can see, the main success factor for finding the correct answer was to correctly define the equivalence partitions. In our opinion, the description of the question could contain additional information, especially regarding equivalence partition, no discount. Share your opinion in the comments to the video. Let us know if you had problems with this question and if you were able to answer it yourself without help. Let's check another example of the ISTQB question. In the new sample exam version 4.0 document, we can find the following question. Those who want to try to answer the questions themselves can pause the video. Let's find the answer to it in the study materials. Our basic approach is to go through all the necessary steps to apply the equivalence partitioning test technique. And we need to start with reading the description of the questions very carefully and try to find information there that can affect the basic approach. Let's check the question one more time. We see a situation different from the previous questions. This time, the equivalence partitions are determined for us, which makes the task much easier. Although we have written equivalence partitions, we still recommend sticking with our approach and visualize them as well as write them down in the form of a table. So we have two variables. Variable 1, pin code length, with 2 equivalence partitions. Variable 2, the number of different digits, also with 2 equivalence partitions. As we have already emphasized many times, when you have non-numeric partitions, it is best to display them as a circle with segments. Everything is simple with the first variable. We have 2 equivalence partitions. One is valid, the other is invalid. With the second variable, we have a typical ISTQB trick, similar to the one used in the previous question. Convert numeric partitions into non-numeric ones. The number of digits is a clearly numeric data type, but in this example, it is defined as non-numeric. The number of digits is either correct or not. It can confuse students, and that's exactly what is designed to do, to confuse. This is the most difficult part of the question, correctly defining the equivalence partitions. Now we will write them in a separate table, where we have all 4 partitions. Let's move to the next step. Usually, when we have 2 or more variables, we have to design tests, but not this time. Let's look at the question again. As you can see, we don't need to create tests ourselves and calculate the coverage. This time we need to check whether the tests cover the specified equivalence partitions. Therefore, we will add answer options with test set to our table and check each test separately. Let's start with answer option A, which has 3 tests, with numbers 1, 2, 3, 4, 1, 2, 3, 5, and only 1. The first test, 1, 2, 3, 4, covers 2 valid equivalence partitions, length correct and number of different digits correct. The second test, 1, 2, 3, 4, 5, covers the second invalid equivalence partition, length incorrect, and only 1 invalid equivalence partitions left to cover. Number of different digits incorrect, and we have the third test with only 1 digit, 1, which is also designed to confuse us, because the invalid partition means that the value pins should be with all digits the same. Since we only have 1 digit, it's hard to say if that fits the definition of all digits being the same. However, according to the explanation of the correct answers, ISTQB handles this as a valid test for an invalid partition. In fact, we think it's a bad test according to ISTQB theory. When values from invalid partitions are used in test cases, they should be tested individually. Therefore, it's a little strange to add an invalid, poorly designed test to the answer options. We understand that nowhere does it say that the tests are well designed. Still, choosing the exact single-digit value is very confusing. Anyway, we have what we have. As a result, we have 3 tests that cover all 4 equivalence partitions. It could be the correct answer. But if you carefully read the description of the question, it says that we must find the minimum number of tests. Therefore, we must consider all answer options. We note that in answer option A, all 4 partitions, 100% coverage was achieved with 3 tests. And we move to answer option B. In fact, we can skip option B because there are also 3 tests. Accordingly, it either repeats the result of answer option A, or it can be worse, covering a smaller number of partitions. We see answer option B covers all 4 partitions with 3 tests. Since answer options A and B have the same result, they are both incorrect. Let's move to answer option C. As you can see, answer option C is most likely the correct answer option. The first value is 1, 2, 3, 4, and the second value is 1. We consider them in the first version of the answer. And we know that these 2 values are enough to achieve 100% coverage. But since this is an ISTQB question, we will look at all possible answers. We see that answer option D covers only 3 partitions out of 4. Accordingly, the largest coverage with the least number of tests has answer option C. This could be a fairly simple question, but answer options with only 1 digit can be very confusing, as well as handling numeric values as non-numeric equivalence partitions. However, now that we know how to handle it, it won't catch us by surprise in the future on a real exam. Let's check one more, the last ISTQB question. In the new sample exam version 4.0 document, we can find the following question. Those who want to try to answer the question themselves can pause the video. Let's find the answer to it in the study materials. Our basic approach is to go through all the necessary steps to apply the equivalence partitioning test technique. And we need to start with reading the description of the question very carefully and try to find information there which can affect basic approach. Let's check the question one more time. There is nothing in the description of the question that affects the first step of using our approach, except that the equivalence partitions, as in the previous question, are already defined for us. We have a set of numerical values that is a little complicated by a simple formula. So we start by defining valid and invalid equivalence partitions. And since the equivalence partitions are already defined for us, we will not need to define invalid partitions ourselves. Let's visualize it. We have 4 equivalence partitions. And since they are numerical, we will draw a line of values. The first equivalence partition is, if D is less than 0, print the error message. Birth year cannot be greater than a current year. It means that the first value of this partition is -1. In this case, it is not critical to know the last value of the partition. The second equivalence partition is, if D equals 2 or greater than 0 or less than 18, then apply the student discount. This means that the minimum value of the partition is 0 and the maximum value is 17. In the same way, we can define the third and fourth partitions. The trickiest point here is the boundaries. They are written differently. Sometimes the value is included in the partition, sometimes it's not. Therefore, you should be careful whether the bracket is square or round. A bracket dash means that the value is included in the partition. A round one means that the value is outside the partition. Brackets correspond to the symbol greater than equal to, less than equal to. You need to be careful with this because it's the main step to the correct answer to the question. We are done with the first step. And we can move on to the second step. But the situation is the same as in the previous question. We don't need to follow the rest of the steps in our checklist. This once again confirms that the application of the technique on the project and the application of the technique to the ISTQB questions are 2 different things. The fact is that we have defined tests for us. Therefore, our task is again only to determine which tests achieve 100% equivalence partition coverage. And we don't need to follow the rest of the steps in our checklist. Let's look at the tests from the point of view of our table. The first test has two values: birth year 1990, current year 2020. This causes certain difficulties because we need the value of D, not the years. In the description of the question, the formula D is indicated. Let D be the difference between the current year and birth year. Accordingly, the D value for the first test is 30. This corresponds to the third equivalence partition. As we said, this is a minor complication, and in general, this question is the simplest of all that we checked in this video. The second test has two values: birth year 2030, current year 2029. And we again need to calculate the value of D, which is equal to -1, according to our simple formula, and thus it covers the first equivalence partition. Therefore, two equivalence partitions are covered by tests, and we come to the most difficult part of answering the question. We have as many as 5 answer options, each of which covers one of the equivalence partitions. And we have to find out which two options cover those partitions that are not yet covered by the tests. As in the previous question, we copied the answer options to our whiteboard. Let's check each of them one by one. The first test case is birth year 2001, current year 2065. We must calculate the value of D based on these values. The formula is simple. D equals the current year minus the birth year and is equal to 64. This value is included in the third equivalence partition, which is already covered by the first test. Accordingly, answer option A does not suit us. Let's check the next answer option in the same way. The second test case is birth year 1900, current year 1965. The value of D in this case is 65, what corresponds to the fourth equivalence partition. This is one of the two equivalence partitions not covered by tests. Accordingly, answer option B is incorrect. One more test case remains to be found. Answer option C is obviously incorrect. The value of D is -65. This value is included in the first equivalence partition, which is already covered by the tests. Let's check the next answer option. The fourth test case is birth year 2011, current year 2029. The value of D in this case is 18. And this value is included in the third equivalence partition, which is already covered by the first test. And this means that answer option E is correct. The fifth test case is birth year 2000, current year 2000. The value of D in this case is 0. This is included in the second equivalence partition. Thus, answer options B and E are two of the test data sets, which should be added to achieve full valid equivalence partitioning coverage for the discount type. As we can see, depending on the question, we can sometimes follow our equivalence partitioning checklist, and sometimes it is not needed at all, because everything is already done for us in the question description. Even more often, the question description contains information that needs to be added, or on the basis of which the steps in the checklist need to be modified. In any case, the checklist helps not to forget the basic rules of using the equivalence partitioning test design technique. For the topic black box test techniques, we have about 50 questions in total. About 10 of them will be related to the section Equivalence Partitioning. It is more than enough for practice. And that's the end of today's tutorial. We hope to see you in the next lecture.